So what we're looking at here is a test setup that we put together to test a tachometer that we actually have procured from Banggood. We wanted to see if it worked for one thing, and also test it out and do some measurements with reference to current draw and also voltage. As you can see here, we've got a rotating disc which is attached to a DC motor, and we've also got the pickup, and located on this rotating disc is the magnet. So what we'll do now is just have a general run through our test setup. So what we have here is the tachometer itself. That is connected to a junction box. Now the output side of the junction box is attached to the tacho, supplying the relevant voltage. Feeding from that goes back to the pickup, which you saw earlier. And coming from the other side of the junction box is the power supply. The power supply we're using for this one is 12 volts, and the power supply itself can provide up to 1.5 amps. Now what this junction box allows us to do is to record current and also voltage. So we can plug in 2 meters, and it just makes it a nice, simple, easy and neat way of measuring. So if we have a look at the tachometer itself, the specifications that are provided, the DC voltages are from 8 to 24 volts. Well, like I said earlier, we're running that at 12 volts. Its draw current is about 30 milliamps, and it can measure from 10 to 9,999 revs per minute with an accuracy of 0.1%. Alright, so let's have a look at what we're actually got going here. So we'll put power onto the system. You can see that the voltage level that the actual power supply is providing is 12.42 volts, and we've got a current draw of about 35 milliamps. Now we've got that set for the 50 milliamp scale, on DC. So what we'll do now is just start up a motor, and we'll just put on about 20%. And as you can see, the tacho has given us a reading of about 532 revs per minute. Now it does take a little bit of time to stabilise initially, but once you get going, we'll take that up to 30%. And the motor is winding up, and the sensor is picking up the pulses, and you can see that we've increased to about 870 approximately. We'll go to 50%. The little DC motor is starting to work a bit harder, and now we're up to 1590 revs per minute. We'll go to 70%. And that's now 2317 or thereabouts. And now we'll go to 100%. That's now 3062. Alright, so we'll just back off from there and take it back down to 0. Alright, so what we've done here is that we've now increased the DC supply to the DC motor, and what we're going to do now is just take it up to 50%. You can see already that we're reading a much higher revs per minute. We take it up to 70%. conclusion of all that, our primary role here was just to test the tachometer itself and to get some specs with reference to the voltage and current draw in the system. We know that the pickup is working well. We know that the tacho is relatively accurate within the voltage range, and it does give us a fairly close approximation to what is being stated. And we also know that with reference to our current draw, it doesn't change appreciably depending on whether we run it at 12 volts and increase the operational revs, or in the second case we're running it at 24 volts and we're increasing the operational revs per minute. Overall, I think it's a success, and we'll be able to use these for a range of applications in our workshops.